At 4:47 a.m., the desert airfield outside Al-Qaryatayn still believed in yesterday's wars. So did the men. Inside the concrete briefing bunker, the ceiling fan pushed thick cigarette smoke in slow, useless circles. Maps were bolted to the wall, their corners curled from years of reuse. Red grease pencil rings marked enemy air corridors. Blue arrows promised control, order, predictability. To anyone who had studied 20th century warfare, it looked familiar in a dangerous way. Like France in 1940, like battles planned for a world that no longer existed. Major Karim Haddad zipped his flight suit and leaned over the table. His knuckles were scarred from years of maintenance work before he earned his wings. He trusted machines because machines, unlike men, followed doctrine, and doctrine was sacred. The intelligence officer spoke with rehearsed calm. Enemy fighters operating east of the mountain line, 2 squadrons, likely defensive patrols. He tapped the map. We commit 3. Numerical superiority confirmed. The room exhaled together. Numbers had won wars before. In 1943, the Red Air Force drowned the Luftwaffe in metal over Kursk. In 1945, mass crushed precision. The lesson had been written into every Soviet manual ever exported, translated, and memorized. Discipline defeats innovation. Karim had memorized those manuals. He had trained under men who once chased Messerschmitts across frozen skies. The system was old, gloriously old, and therefore trustworthy. Outside, floodlights illuminated rows of MiG-23s, their swept wings glistening with condensation. Ground crews moved with quiet efficiency, hands black with fuel and grease. Checklists were clipped, panels were sealed, green lights across the board. These were not obsolete aircraft. These were upgraded interceptors, delivered fresh from Eastern Europe less than 2 years earlier. New radar sets, improved climb rate. On paper, they could meet anything the enemy owned, and paper had always been the beginning of victory. Karim climbed the ladder into his cockpit as the horizon softened from black to steel gray. He strapped in, connected his oxygen line, ran his checks. The radar scope flickered to life. Alive, noisy, imperfect, familiar. His warning receiver was silent. That mattered. From the control tower, the voice of ground command came through his headset. Calm, authoritative, absolute. Headings, altitudes, timing. The voice that replaced uncertainty with certainty. The voice that told pilots when to think and when not to. In World War II, ground control had been revolutionary. Britain survived the Blitz because of it. The Soviets mastered it because of necessity. Karim believed in it with the faith of a man who had never seen it fail catastrophically, only slowly. Engines roared. One by one, the fighters rolled forward. Karim pushed the throttle and felt the aircraft surge, the runway dropping away beneath him. The MiG climbed hard into the morning sky, wings slicing clean air over unfamiliar mountains. Formation locked, spacing perfect, doctrine flawless. At altitude, Karim switched to search mode and waited. Static. Terrain returns. Ghosts. Ground command would speak soon. They always did. Somewhere, radar operators were tracking enemy blips, calculating intercept solutions, deciding the future in calm, windowless rooms. Karim's hand rested near the weapons selector. He felt no fear, only focus. This was how wars were won. By systems, by obedience, by repetition. What he did not know, what no one in that sky knew, was that the war had already started, and it did not look like anything written in their books. 30 miles away, unseen and unannounced, another kind of air force was already watching them breathe, and in the next moments, the sky itself would betray every rule Karim trusted. The radio came alive with a voice that carried panic instead of protocol. Major Karim Haddad banked hard to starboard, following the sudden heading called out by ground command. His MiG-23 responded perfectly, the hydraulics smooth, the engine obedient. But perfection mattered little now. Karim had no way of knowing that the world around him had already betrayed him. 90 seconds earlier, unseen, a radar system had locked onto him and 4 of his comrades. Each blip on the screen was a life measured, calculated, chosen for destruction by an enemy pilot, calmly sipping coffee 30 miles away, whose mind had already decided which aircraft would vanish first. At 4:59 a.m., the first missile tore through the morning sky. No flash, no warning. The AIM-7. Sparrow struck silently, shredding hydraulics and control surfaces before his brain even registered danger. Karim's cockpit erupted in chaos. The ejection seat fired automatically. He was airborne, suspended under the canopy, while behind him his wingman was already gone, consumed in an instant fireball. 40 seconds later, 2 more MiGs went down. The radio was a tornado of static and frenzied shouts. Ground command barked vectors that had made sense 3 minutes ago, now useless and fatal. Syrian pilots hunted invisible enemies through cluttered radar screens, while Israeli F-15s circled calmly at 15,000 feet above, their radar omniscient, their pilots untouchable. The rules had changed. The Americans had built this war around one principle: see first, shoot first, survive. Syrian pilots were flying blind into a slaughterhouse. Captain Samir Al-Tayeb, in a MiG-21 trailing the formation, managed to lock onto a faint return. Enemy or phantom, he could not tell. Desperation made him fire. His R-60 missile wobbled away, engine igniting, but almost immediately succumbed to electronic interference. Within 3 seconds, an Israeli AIM-9 Sidewinder found the heat of his engine and ended his fight. His final words on the radio were static, then silence. By 5:20 a.m., 16 Syrian aircraft had become burning wrecks scattered across the valley. Israeli pilots described it later as practice intercepts, except the targets didn't return. The sky that had been a network of disciplined formations 15 minutes earlier was now a broken map of spiraling black smoke and fading contrails. Damascus ground control tried to salvage order, calling vectors for planes that no longer existed. Soviet radars blinked in confusion as clusters of aircraft vanished faster than the operators could track. Orders were given against enemies who were already miles away, unseen, untouchable. Doctrine assumed visibility. Reality assumed slaughter. Lieutenant Bashir Naim ejected over friendly territory, engine dead. He drifted beneath the canopy, witnessing 3 more fighters fall in silent arcs beneath him. Each plume of black smoke a monument to failure, a testament to the brutal efficiency of the unseen enemy. By 6:05 a.m., the battle was over. 82 Syrian aircraft destroyed. 0 losses for the opposition. Israeli pilots, still in the air, reported Winchester, out of missiles, returning to base to rearm. Their system designed to harvest targets at will, to train, to dominate, to teach the sky that human courage meant little against invisible precision. The survivors, scattered and shaken, descended into a world they had once understood, now a landscape of fire, smoke, and shattered doctrine. The war had proven a simple truth. The sky could betray the trained, the disciplined, and the confident as easily as it could serve the cunning. To be continued in Part 3, the aftermath, the shock, and the desperate struggle to understand a battlefield that had ceased to obey the rules. By midday, Al-Qaryatayn airfield was quiet in a way that made the silence scream. Ground crews counted returning aircraft, their eyes widening as the numbers refused to add up. Squadrons that had launched together 2 hours ago were now shadows of themselves. Charred wreckage, flaming craters, and scattered parachutes across the Bekaa Valley. Maintenance officers who had signed off on each MiG were now confronted by Soviet advisors, their voices tight with disbelief as they tried to explain a doctrine that had evaporated mid-air. Major Karim Haddad, tangled in the folds of his parachute in a scrubby field, looked up as Israeli F-16s streaked overhead. The clarity hit him like a hammer. Everything he had been taught, drilled on, and memorized in Soviet flight schools was now obsolete. The doctrines, the formations, the intercept procedures, all had died alongside 81 of his comrades. American engineering had rewritten the rules of aerial warfare in a single morning. It was not a first. History whispered warnings. The humiliation began in 1965 over Vietnamese skies when F-4 Phantoms began dropping like leaves in autumn. Each $3 million aircraft carried radars heavier than entire World War II fighters. Yet MiG-7s, subsonic relics from a decade prior, were carving them out in tight-turning fights. The Air Force watched in horror as gun camera footage revealed Phantoms bleeding energy and vertical scissors, trained for beyond visual range engagement, now forced into fights they couldn't win. Inside a Pentagon office in 1966, Major John Boyd scrawled equations across whiteboards, frustration and obsession burning in his eyes. Energy maneuverability theory, he called it. A mathematical lens through which every fight, every climb, every turn could be predicted, measured, and optimized. His calculations confirmed what Vietnam had shown. Even the most expensive advanced aircraft was powerless if it could not maintain energy during combat. Boyd's work laid the blueprint for a new era. Fighters would no longer be designed solely to launch missiles from afar. They had to outmaneuver, out-accelerate, and outlast the enemy. The Air Force codified this in the FX, Fighter Experimental Requirement. 1967, an aircraft that could dominate in dogfights and beyond visual range, regardless of Soviet countermeasures. By 1969, McDonnell Douglas delivered a design that looked aggressive even on paper. Twin tails, shoulder-mounted wings, twin Pratt and Whitney engines, each generating 25,000 pounds of thrust. The aircraft could reach Mach 2.5 while enduring 9 Gs, sustaining turns without bleeding critical energy. The very flaw that had doomed Phantoms over Vietnam. In June 1972, the prototype YF-15 rolled off the St. Louis line in test colors of blue and white. Chief Test Pilot Irving Burroughs strapped in on July 27th, throttling the twin F-100 engines to a combined 50,000 pounds of thrust. The aircraft lifted off after barely 900 feet. 40,000 pounds of war machine felt like half its weight in the air, responding instantly to every command. Burroughs pushed the fighter through every envelope. Turns, climbs, dives. Acceleration pinned him to the seat. Stability allowed seamless formation flight, and energy bleed, once the silent killer of Phantoms, was now a controlled variable, manipulated at will. The engineers had solved problems Soviet designers didn't even know existed. Yet performance alone could not win wars. Sensors had to match the fighter's potential. The F-15's nose housed the Hughes ANAPG-63 radar, capable of tracking multiple targets simultaneously while maneuvering at high speed. Pilots could engage 6 targets before any of them realized they were under attack. Soviet radars, by contrast, required steady, level flight to maintain lock, a vulnerability that would be fatal in real combat. January 1976, Langley Air Force Base. The first operational F-15A roared down the runway, its engines singing with the promise of a future other fighters could not touch. Pilots strapped in and reported the impossible, an aircraft that felt alive, that moved as though it anticipated their thoughts, transforming Mach 1.5 intercepts into routine maneuvers. The sky was no longer just a battlefield. It was a canvas, and the F-15 its brush. Production accelerated through the late 1970s, and by December 1976, Israel received its first F-15A Baz, Falcon in Hebrew. Pilots who had flown nimble French Mirages now stared in awe at a machine that was not merely superior, but belonged to a category of combat entirely its own. They had no way of knowing they would demonstrate that dominance in Lebanon less than 6 years later, over valleys where Soviet doctrine had promised invulnerability. Meanwhile, in Culver City, California, 1970, Radar engineers at Hughes Aircraft faced a challenge that had haunted combat aviation for decades: ground clutter. Traditional pulse radars could not distinguish between an enemy fighter at 20,000 feet and a ridge 30 miles distant. Both returned energy. Both appeared on the scope. Pilots scanning low-level targets often saw only noise, while adversaries maneuvered unseen through valleys, ridges, and defiles. Engineer Tom Amley led the team developing the pulse Doppler radar for the AN/APG-63, working in a lab where oscilloscope traces determined life or death for pilots far away. Pulse Doppler exploited the Doppler effect, the shift in frequency when radar waves bounced off moving objects. An aircraft rushing toward the radar returned a signal measurably different from stationary terrain, allowing the system to filter out everything that wasn't moving. The clutter disappeared. The targets remained. The first airborne test came in 1972, mounted in a modified F-4. Ground returns vanished from the screen, leaving only the fighter to track. Valleys, ridges, and terrain features that would blind conventional radar no longer mattered. The system could follow 6 targets simultaneously, calculating velocity vectors, predicting positions, and maintaining individual track files updated 4 times per second. Hughes engineers added track while scan capability, a feature that would soon make Soviet designs look archaic. The MiG-23's RP-23 radar forced pilots to choose search mode or track mode. Choose wrong, and death found you. The AN/APG-63 could do both at once. Its tactical display showed range, altitude, closure rates, and optimal firing solutions for every threat within 100 miles. A pilot could see 6 enemies, know which to engage, and understand the probability of kill before a missile left the rail. The radar's computer, a 65-pound Texas Instruments unit, could calculate in-flight solutions once needing 3 mainframes. By 1976, Israeli pilots trained relentlessly against the Baz, learning to trust the radar as instinct. Every exercise, every sortie, every dogfight scenario prepared them for the moment the system would matter most. A day when doctrine and numbers meant nothing, and survival relied entirely on seeing first, striking first, and outthinking the enemy. In Lebanon, 1982, the time came. Major Karim Haddad, tangled in his parachute and staring at the silver streaks of enemy fighters above, had just witnessed the sky betray everything he knew. Unknown to him, engineers in Culver City had already given the Israeli Falcons the eyes and the brain to turn the Bekaa Valley into a proving ground. The F-15 Baz, pulse Doppler radar humming, advanced avionics tracking every Syrian MiG like chess pieces on a board, was about to make history. And in that moment, every pilot who had trusted doctrine, numbers, or training would learn that technology could rewrite reality in the blink of an eye. To be continued in Part 5. The execution of the ambush, the fall of the Bekaa Valley, and the human reckoning as doctrine and bravery collide with machine perfection. By 1982, the nature of air combat had changed forever. Major Karim Haddad and his fellow Syrian pilots were still thinking in terms of skill, formation, and numbers. Lessons drilled into them in Soviet simulators. But their enemies no longer played by those rules. Israeli pilots had been handed a new weapon: information itself. The fight was no longer about reflexes or bravery. It was a contest between sensor systems. The side that saw first dictated the battle. An F-15 pilot tracking 6 targets while maneuvering could fight outnumbered and win. Syrian pilots, trained to operate with synchronized ground controllers, still depended on 6-second updates from surveillance radars obscured by terrain. They flew blind into zones already mapped for destruction. Israel had taken the AN/APG-63 radar a step further, integrating it into a network via Elbit-designed data links. Radar tracks became shared intelligence across formations within a 50-mile radius. Every pilot could see the same picture in real time. Every MiG in the Bekaa Valley was a ghost on the scope, invisible, untouchable, yet utterly predictable. Syrian radars spat back clutter and hills while missiles closed from directions they could never detect. But the Americans were not done. In 1972, Fort Worth, General Dynamics engineers faced a new problem. The F-15 was too effective. At $18 million a copy, the Air Force could not field enough Eagles to cover every base, every strike, every mission. What they needed was a fighter that traded some capability for numbers, speed, and agility. Enter Harry Hilliker, designing what pilots would eventually call the electric jet. The YF-16 was a miracle of lightweight engineering. A single Pratt & Whitney F-100 engine, the same power plant as the F-15, housed in an airframe 12,000 pounds lighter. The result? A thrust-to-weight ratio exceeding that of the F-15, acceleration like a rocket, and sustained 9 G-turns at full combat weight. The first prototype flew January 20th, 1974. Test pilot Phil Ustriker reported handling so intuitive it felt like the aircraft anticipated his thoughts. But the true revolution was hidden inside. Fly-by-wire controls, mechanical cables and hydraulic boosters, the legacy of a century of aviation, were gone. Every stick input traveled as electrical signals to a computer that translated intent into precise control surface movements. The F-16 was aerodynamically unstable. Left alone, it would tumble. But the computer corrected hundreds of times per second, giving pilots maneuverability impossible for traditional designs. A side-stick controller on the right console replaced the conventional center stick, reducing pilot strain under high Gs. Pressure sensors translated a light push into a 9G turn, allowing the pilot to focus entirely on the fight, not the controls. By the time Major Karim and his surviving squadron limped back to Al-Qaryatayn, they were confronting a reality they could barely comprehend. Machines and networks had overtaken human reflexes. Their doctrine, their training, their courage. All were now operating in a world where seeing first and controlling information was the ultimate weapon. And above them, Israeli F-15s and F-16s cruised like predators. Every radar return known, every movement anticipated, every missile ready. The war in the skies was no longer about skill or luck. It was about who had the eyes to see and the brains to act on them first. To be continued in Part 6. The Bekaa Valley battle from the Israeli perspective, showing how technology, training, and nerves combined to rewrite air warfare. By 1979, the first production F-16A rolled out of General Dynamics' assembly line. Pilots reported a machine that felt alive, one where computers anticipated their intent faster than the mind could act. That same year, Israel ordered its first batch, modifying them with homegrown avionics and weapons. Pilots transitioning from A-4 Skyhawks, subsonic relics of the 1950s, suddenly found themselves in aircraft capable of climbing 50,000 feet per minute, carrying the same pulse Doppler radar that had already made the F-15 lethal. The F-16 was no longer just a lightweight fighter. It was a multi-role air superiority system, able to strike ground targets, provide close air support, and dominate dogfights with equal skill. Israeli engineers integrated Python 3 and Shafrir missiles, ECM pods jamming Syrian radars across multiple frequencies, and targeting pods for precision strikes. By 1982, Israeli F-16s could strike a target and seamlessly transition to air combat with the same radar advantage as the F-15. Operational costs were exactly as Hilliker had predicted, half the F-15 per flight hour. Israel could maintain larger patrols, fly more hours, and train aggressively. Pilots logged twice the flight hours of their Syrian counterparts, practicing high-G maneuvers and radar intercepts that the fly-by-wire system made possible. Syrian pilots, meanwhile, were still mastering Soviet doctrine in mechanically controlled aircraft, where one mistake could send them spiraling out of control. On June 9, 1982, Israeli F-16s and F-15s launched toward the Bekaa Valley, carrying the same beyond visual range missiles, the same pulse Doppler radars, and the same network integration that made their aircraft so dominant. To the Syrian MiGs, The smaller F-16 was indistinguishable from its larger F-15 sibling until the missiles found them. Behind the scenes, Elbit systems engineers in Haifa had solved a problem American designers hadn't anticipated, linking fighters into a real-time network. The Israeli Air Force now had American aircraft, but with doctrine and tactics uniquely suited to shared situational awareness. Individual performance no longer mattered. Pilots operating on outdated data died. Pilots operating in the network survived and dominated. The solution: the Elbit C3 data link system. A pod mounted on the F-15 centerline transmitted encrypted radar tracks across the formation. When a radar detected a target 80 miles away, every pilot within 50 miles saw it instantly. The formation commander built a composite picture, eliminating blind spots and coordinating engagements against superior numbers. Syrian pilots, relying on ground controllers and 6-second-old radar updates, flew blind into a kill box. Israeli pilots made decisions in sub-second time. The network didn't stop at airborne data. Ground-based Hawkeye early warning stations in northern Israel scanned 200 miles into Lebanon, feeding live tracks directly into the system. Syrian aircraft were pre-targeted before they even left Damascus, the Bekaa Valley, a meticulously mapped ambush. Israeli commanders positioned F-15s in high-altitude combat air patrols, while F-16s orbited lower, creating layered coverage where overlapping pulse Doppler radars left no altitude band unmonitored. As Major Karim Haddad and his remaining pilots approached the valley, unaware of the invisible web surrounding them, they were entering a battlefield where information was the deadliest weapon. The sky was no longer a contest of skill or courage. It was a trap of sensors, computers, and data, one in which every mistake would be fatal and every advantage irreversible. To be continued in Part 7, the first missile salvo, the collapse of formations, and the moment when doctrine meets modern warfare. 60 miles out, the Syrian formations appear on Israeli screens like pieces already placed on a chessboard. They are climbing, disciplined, precise, and completely exposed. Before Syrian ground controllers can issue their first updated vectors, Israeli pilots are already watching predicted tracks curve across their displays. The data link turns dozens of individual cockpits into a single thinking organism. 4 Israeli fighters engage 12 Syrian aircraft at once, not by chance, not by instinct, but by assignment. Every pilot knows which targets are his. Every missile launch is coordinated. Nothing overlaps. Nothing is wasted. This is no longer combat. It is choreography. Then the advantage multiplies. High above Israeli territory, invisible to Syrian pilots, an E-2C Hawkeye circles patiently. Israel received 4 of these airborne early warning aircraft in 1981. Each carries a rotating radar dome housing the ANAPS-145, scanning 250 miles in every direction. It sees everything: fighters lifting off from Damascus, formations forming, altitudes climbing, headings stabilizing. The Hawkeye does not fight. It simply tells the truth, instantly. That truth flows straight into the Elbit data link network. Israeli F-15 pilots now know where Syrian aircraft are before the Syrians themselves understand the battle has begun. Intercept geometries are calculated while MiGs are still climbing through thin air. Ground controllers in Damascus are working with 6-second-old radar pictures. Israeli pilots are acting on information less than 1 second old. The Soviet system assumes ground radars are enough. The Israelis have built a nervous system. Airborne radar, ground stations, fighter radars, all fused into one continuous picture. After the battle, Syrian commanders will stare at reports in disbelief. Israeli pilots called out enemy positions Syrian radar never saw. Missiles arrived from angles doctrine said were blind spots. Engagements coordinated across 40 miles of airspace, executed with a precision that should not exist without direct visual contact. This is not a failure of courage. It is a failure of time. The Syrians are fighting with 1960s coordination against 1980s networked war. The gap is not speed or maneuverability. It is how fast knowledge moves, and below it all lies the final shield: the Bekaa Valley SAM belt. 19 SA-6 gainful batteries, 8 SA-2 sites, 2 SA-3 complexes, a web of radar-guided missiles designed by Soviet engineers whose professional ancestors learned to stop German bombers over Stalingrad. On paper, it is lethal. Overlapping engagement zones, mobile launchers, semi-active radar homing systems that have killed Israeli aircraft before. Syrian battery commanders follow doctrine perfectly. Radars sweep, missiles wait. Crews are ready to fire the moment a target enters range. Israeli planners in Tel Aviv study reconnaissance photos and understand the truth immediately. You do not fight inside this web, you erase it. They borrow a lesson written in blood over Vietnam. First, suppress enemy air defenses. Second, achieve air superiority. Third, strike at will. On the morning of June 9, 1982, that plan goes into motion. The Bekaa Valley is not a battlefield anymore. It is a laboratory. And within hours, the most advanced Soviet-designed air defense network outside Eastern Europe will cease to exist. Not because it malfunctioned, not because its crews lacked skill, but because it was never built to fight an enemy who could see everything, share everything, and decide everything faster than human thought. For Major Karim Haddad, watching smoke columns rise where radar sites once stood, the realization finally settles in. The sky did not defeat them. Time did, and air warfare would never be the same again.